We're going to look at scaling up, scaling down, and scaling to 10 in ratio tables. Remember that a rate is a comparison of two related quantities, like feet per second, miles per hour, pancakes per person. A way to find equivalent or equal rates is to use a ratio table. Within the ratio table, scaling up, scaling down, and scaling to 10 would help us find equivalent ratios. And when I talk about scaling up, scaling down, scaling to 10, what I mean is that you're using multiplication or division to find those equivalent ratios. Remember, in a ratio table, what you do to one side, you have to also do to the other. That's what helps you maintain equality. So let's look at a few examples. So my first example, I see in the input side, the X value side, I have a 5, and that 5 is related to the 7. There's 5 units to 7 units. And I'm trying to get an equivalent ratio where the X or input value is 6. I'm going to start here. I know that 30 is a common factor of 5 and 6. So I'm going to multiply 5 times 6 to get to 30. Because I'm going to a larger value, that's what I mean by scaling up. Now, if I've multiplied this side by 6, I have to also multiply this side by that same number. 7 times 6 is 42. So here I have an equivalent ratio, but I haven't yet gotten to this value. The next thing I'm thinking is I could get from 30 to 6 by dividing it by 5. Now, that could be a good plan. However, 42 is not evenly divisible by 5. So I'm going to look for another option. I know that I could divide 30 by 10. When I divide anything by 10, that's a skill. Like, I just know quickly that that means I would move the decimal one place to the left, which would give me 3. That's helpful over here. Since 42 wasn't evenly divisible by 5, it's also not evenly divisible by 10, but I could use that strategy of moving the decimal one place to the left, which would give me 4 2/10. So here is another equivalent ratio. And that was easier for me to do without a calculator than dividing by 5. That's why I did it that way. Now, I'm looking at going from 3 to 6. This is, I have scaled down, scaled down. Well, going from 3 to 6 is going to be a scale up since 6 is bigger. And that's simply done by multiplying by 2. 3 times 2 is 6. And now I have a pretty easy mental computation here as well. So I multiplied by 2 on the left. I'm going to multiply by 2 on the right. 4 2/10 times 2 would give me 8 4/10. And there's an equivalent ratio with scaling up to scale down. Let's look at another example. Here I've got 20 to 7, and I'm trying to find an equivalent ratio where the first value is 15. My first thought here, I could divide both of these by 2 to start getting something that might be a little easier to maneuver up to 15. I don't know a number. Like, I'm not sure what I would multiply by 20 to get to 15 off the top of my head. So here we'll divide both sides by 2. Whoa. 20 divided by 2 is 10. Half of 7, or 7 divided by 2, would be 3.5, or 3 5/10. Now, I still am thinking, to get from 10 to 15, I would have to multiply that by a number that's not a whole number. So I'm going to divide by 2 again. Let's see what happens. So here I am scaling down again. So I've divided this by 2. 10 divided by 2 gives me 5. And now I'm going to do 3.5 divided by 2. This one, I think about money. That helps me do this mentally. If I have $3.50, I know that half of that would be $1.75. All right, now I've gotten somewhere. I'm seeing now an easy way to get from 5 to 15. I could scale back up and just multiply that by 3. And remember, what I do on this side, I'm also going to do here. So 1 75/100 times 3 gives me 5 25/100. So I know that 20 to 7 is an equivalent ratio to 15 to 5 25/100. Let's look at one more option here. Scaling to 10 to find the unit rate is a good idea because if I can scale the numbers to 10, dividing by 10, as I said above, is as simple as just moving the decimal to the left. So that's why I'm choosing to scale to 10 in this example. I need to get from 12.5 to 30 to a unit rate with 1 here. My first instinct, I know that 12.5 is half of 25. So I'm going to multiply by 2. Because I multiplied by 2 here, I'll multiply by 2 here, and that would give me 60. All right, 2.5 is still not a number, or sorry, 25 is still not a number that's easy to scale right to 10. But I'm thinking 25 times 4 gives me 100. And now, if I've multiplied this by 4, I'll multiply 60 by 4, which would be 240. I can scale to 10 now. I can see it. To get to 10 here, I would have to divide 100 by 10. And so that's what I'm going to do. Now, because I divided by 10 here, I would divide by 10 here. 240 divided by 10 would leave me with 24. And finally, to get from 10 to 1, that's scaling to that unit rate, I would divide by 10 again. And 24 divided by 10 gives me 2 4/10. So those are 3 examples of how I could use ratio tables, and I can scale up and down, or down and up, or scale to 10 in order to find equivalent ratios.